Bless your heart. Some kind of way you done found yourself for the online tutoring of Mr. Whittington's. Is it Mr. or Mr.? Mr. Whit? How that man say that? Anyway, today's episode is on factories. Now, I don't know what in this Sam here any of this means, but I hope you enjoy yourself, so get your ink pen and your pencil and get ready to learn about factories.
Hello, ladies and gentlemen. This is Mr. Whit with 4Ben Tutoring, and today's tutorial is going to be about the greatest common factor, the GCF, factoring out the GCF. All right? It's fundamental to factoring, ladies and gentlemen. In fact, it's the first thing you should do anytime they ask you to factor anything. Yeah, it's the first step. So you got to know how to do it. So the greatest common factor, the GCF, ladies and gentlemen, is simply requesting the following. They're asking, what do these terms have in common? That's it. That's all they want. Once you have that, you can factor it out, okay? So what we'll be doing, ladies and gentlemen, in this lesson is we'll be finding the GCF and also factoring it out. Oh, yeah. That's what we'll be doing, okay? So two parts. So in problem 1a here, I have 3x plus 9. What I prefer to do is compartmentalize the process, all right? I do it in parts. I do it in pieces. The first thing I'm looking for is a common number, a common coefficient. That's what I'm looking for first. Then I check out each of the variables in order, all right? So as I look at 3x plus 9, the first thing you should think about is how many terms you have in this expression. Well, terms are separated by plus or minus signs. Okay? So here I have a plus sign, so that's going to separate the first term, which is 3x, from the second term, which is positive 9. These two terms have 3 in common. Yeah, because 3 goes evenly into 3x and 3 goes evenly into 9. That means that my GCF in this problem is 3. But we're going to factor out the 3, which means that we're doing the opposite of the distributive property. That's right, we're going to be dividing. Since the distributive property is related to multiplication, the opposite of that would be, in this case, factoring, where you'll end up with a product as a result. You'll end up with two things multiplying together, okay? So that means I'll be opening up a set of parentheses to show that multiplication, and after factoring out, aka dividing out the 3 from 3x will leave me with x. All right? Then 3 goes into 9 how many times? Exactly, 3 times, so I'll have a positive 3 here. And then that'll be the result. This is my answer, ladies and gentlemen. You know that you have factored out the GCF correctly when your set of parentheses here doesn't have anything in common other than 1. So since x and 3 don't have a common factor, that confirms that 3 is my GCF, and this is the result. Can't do anything else with this. So I'm going to put a red box around it because that's the way I like to write my answers. All right, just like so, ladies and gentlemen, done and done. Now, anytime you want to verify that this result is the answer, all you have to do is just multiply it back together. So 3 times x is 3x. 3 times 3 is 9. Well, that's it. That verifies it. Done and done. All right, let's look at 1b now. 1b. We have x squared plus 3x, ladies and gentlemen. X squared plus 3x. Now, we're going to be looking at these two terms. It's a binomial. And you want to find out what they have in common, right? So I see that these two terms have what in common? Exactly. You already saw it. They have an x in common. So as I factor out x, what you'll do is you'll always take the lowest exponent on your variables. Your first term has an exponent of 2, and this variable x here, since you don't see the exponent, you know that it's just 1. X to the first power is x. All right, so I'm taking out that lowest exponent. In other words, I'm factoring out just x to the first power, and then I'll open up my set of parentheses here and write down what's left over after I divide away that 1x. So x goes into x squared, x times. Yes, it does. And then x goes into 3x 3 times. Like so. All right. And I know this is the answer, ladies and gentlemen, because x times x is x squared, and x times 3 is 3x. So that's it. All right. Hope you're having fun. Let's continue on. In problem number 2, we're looking for the GCF, and we're going to factor it out. So in 2a, I have 6x to the 4th power minus 10x cubed plus 3x squared. I like to factor in parts here. So I'm going to look at my coefficients first, the values in front of my variables here. And I have 6, negative 10, and 3, right? Okay, well, those three numbers don't have anything in common other than 1. So that means I can't factor out any common number. But they do have the variable x in common, don't they? Yes, they do. So you're going to always factor out your variable with the lowest exponent. So here I have an exponent of 4, 3, and 2. So the lowest exponent on this is 2. So I'm going to factor out x squared. This will leave me, as a result, 6x to the second power. See, what you do is you're going to bring down your coefficient and you'll subtract away the exponents, all right? So you'll have 4 minus 2. Remember, we're dividing, so when you're dividing like bases, you subtract the exponents. So 4 minus 2 gives me x squared right there. All right, then factoring out x squared, or taking away 2 x's from that negative 10x cubed term, I'll end up with negative 10x. All right, because the 3 minus the 2 left me with 1x there. Then factoring out x squared from my last term of 3x squared, I'll just have a positive 3 left. All right, because I had 2 x's, I just took those 2 x's away, so you don't have any x's left over for that term. And that's it. That's the result. You got it. Now, in future problems, you will be checking to make sure that this trinomial cannot be factored, and it cannot in this case. So this is your result, ladies and gentlemen. Okay? That's the answer. I'm going to red box it. Okay? So here we go. My red box. There we go. So you know that's the result there. Just like that. Okay. Next problem. In 2b, we have 9x to the 4th power y squared minus 15x cubed y plus 3x squared y. That's right. We have 3 terms. So I'm going to look at the coefficients first, then the variables. So looking for my GCF before I factor it out, I'm going to have 3 in common between those 3 values, and then I'm also going to be able to factor out x to the second power because they all have an x, and the lowest exponent on my variable x is 2, and then I can also factor out y to the first power. Looking at your variable y, I have an exponent of 2 here, exponent of 1, and an exponent of 1, so that means that the lowest exponent on y is 1. So I end up with a GCF of 3x squared y. All right? And be careful with your directions, ladies and gentlemen, because sometimes they can just ask for the GCF, or they can say factor out the GCF. So if they just want the GCF, you'll just give them 3x squared y, and that'll be the end of it. But if they are asking you to factor out the GCF, then you continue into our next step, which will be to open up a set of parentheses here and write down the result of dividing away 3x squared y from each of these 3 terms here. So 3 goes into 9 3 times. Me taking away 2 x's from the 4 that I had leaves me with x squared. I've taken away 1 y from the y squared there to leave me with a y. All right, and then 3 goes into negative 15, negative 5 times. Me taking away 2 x's from the 3 that I had in that second term leaves me with 1x. Me taking away the only y I had leaves me with no y's now. And then, ladies and gentlemen, check out this last one here. I'm factoring out 3x squared y from 3x squared y. Remember, I said earlier that factoring is division. So in other words, I'm asking how many times will 3x squared y go into 3x squared y? Well, that'll just be 1 time. And you have to write the 1, ladies and gentlemen, okay? Remember, this product is supposed to end up giving your original problem here. So 3x squared y times 3x squared y is 9x to the 4th power y squared, and 3x squared y times negative 5x is negative 15x cubed y, and then finally 3x squared y times 1 is 3x squared y. So that works out just fine. And what you have inside the parentheses here cannot be factored. That's important. You need to always make sure that your parentheses are completely simplified and factored. All right. There you have it, ladies and gentlemen. That was 2b, and now we're going to be moving on to our next problem, which is problem number 3. Now, when factoring out your GCF, ladies and gentlemen, it's a great, wonderful, always do practice to factor out a negative something anytime your first term is negative. In most cases, you definitely want to rewrite your expression in descending order of your variable, okay? But in our problem 3a, we just have negative 2xy minus y. All right, so this is how I'm going to attack the problem. I know I'm going to factor out a negative something. Why? Because the first term is negative. Then these 2 terms, they have y in common. So it turns out that my GCF is negative y. All right? And it's not because they're both negative, it's because the first term is negative. So always factor out a negative something anytime your first term is negative, all right? And please make note, that's after you make your expression in descending order, okay? So do that first. So here I'm factoring out a negative y. That's going to leave me with the following. It's going to leave me with 2x here. All right, because negative y times 2x is negative 2xy. Then negative y will go into itself a positive 1 time. Okay, so I write down positive 1. Remember, this has to multiply to get me back to the original. So negative y times 2x is negative 2xy, and negative y times 1 is negative y. I'm done. That's the end of 3a. Just like that. Done and done. I'm putting the box around it. I'm moving on to that next problem here. I'm about to read it to you. Negative 12c cubed d plus 3c squared d to the 4th power. I have how many terms here? That's right, 2 terms. And the first term, ladies and gentlemen, is negative. Also make note that this is in descending order of c. All right, because here I have c cubed, second term c squared, so it's going down. All right, the exponents are going down in regards to your c variable. And I'm going to factor out a negative something here. All right, I'm going to factor out a negative 3 as my coefficient because 3 goes into 12 and 3 in the first term is negative. So I got to factor out a negative something, right? And then looking at my variable c, I'm going to take the lowest exponent on c, which is 2, and I'm going to take out the lowest exponent on d, which is 1. So my GCF is negative 3c squared d. Right. And now I'm going to factor that out of the expression. So opening up my set of parentheses here, negative 3 goes into negative 12 a positive 4 times. Taking away the 2 c's from the original 3 that I have will leave me with 1 c, and I'm taking the only d I have from that first term, so I just end up with 4c as the first term inside the parentheses. From there, negative 3 goes into positive 3 negative 1 times. Okay, because a negative times a negative is a positive. Okay, then after taking away the 2 c's from that second term, I don't have any c's left, and I'm only taking away 1 d from the d to the 4th power to leave me with d cubed, which is my answer here. And that's it. Remember, in order to verify your result is correct, go ahead and multiply it back together. So negative 3c squared d times 4c will give me negative 12c cubed d. Then multiplying negative 3c squared d times negative d cubed, you'll end up with a positive 3c squared d to the 4th power. And that's the answer. Putting the box around it. And there we have it, ladies and gentlemen. That was 3b, as in boy. Let's move on to our next problem. In problem number 4, we have the following. We have x cubed times the quantity of a plus b minus 5 times the quantity of a plus b. My question to you is this. How many terms do we have in this problem? How many terms are in this problem? Remember that terms are separated by plus or minus signs, right? So I have one term in this x cubed times a plus b, and I have another term which is negative 5 times a plus b. So we only have 2 terms in this expression. Now that we know we have just 2 terms, what do those 2 terms have in common? Exactly. They have the a plus b in common. So a plus b, ladies and gentlemen, is my GCF. So I'm going to factor out a plus b, open up a set of parentheses here. Yeah, that is an ugly b, isn't it? Let's fix it. Let's fix the ugly b. That's a little better, just a little better, but we'll take it. What's left over now, after I've factored out that a plus b, is going to be what's left over, which is the x cubed minus 5. So we'll place that into our second set of parentheses here. All right, and this is going to be my answer. That's it. So what happened, ladies and gentlemen? I recognized that first I had 2 terms, and then I recognized that a plus b is what those 2 terms had in common. So I'm factoring out a plus b as the GCF. Remember, the factoring process is division. So dividing away an a plus b from the first term left me with x cubed. Dividing away an a plus b from the second term simply left me with the negative 5 there. And that's the result. That's it. I can't do any more with that, so I'm going to box it up. All right? And that's the answer to 4A. All right, good stuff. That was a good problem. Problem 4B. We have the following problem. We have 2x squared times the quantity of 4x minus 3 plus 3 times the quantity of 4x minus 3. And what we want to do here is recognize that we have two terms. That's right. We have these two terms separated by that plus sign right there. And these two terms have what in common? Say it. Very good. You have 4x minus 3 in common. Absolutely. So that means that I'll be bringing down that GCF, which is 4x minus 3, and writing down in parentheses what remains. All right. So after I factored out that 4x minus 3, that first term, I'm left with 2x squared. And then from the second term, after factoring out 4x minus 3, I'm left with a positive 3. Just like that, ladies and gentlemen. Done. Done, son. All right, about to put a box around that. There we go. There we go. That's the result of 4B. All right, let's see what's next. Let's see what's next. Let's see what's next. We have problem number 5 here. And in problem number 5A, we have 3/4 x cubed plus 5/4 x squared plus 7/4 x plus 1/4. A lot of fourths going along, right? So if you were listening, you should have heard fourth in every single term. And remember, we have 4 terms here because terms are separated by plus or minus signs. So I have 3/4 x cubed as a term, 5/4 x squared as a term, 7/4 x as a term, and 1/4 as a term. 4 terms. These 4 terms have 1/4 in common. That's right. They all have a denominator of 4. So that's my GCF, ladies and gentlemen. Let your eyes do the work for you. You see a 4 in every denominator. That's what they have in common. All right, so factor out the 1/4. Now, it's not as bad as you're saying. Since I'm factoring out 1/4, we're simply going to take away, steal the 4 from each of these terms in the denominator, which will leave me with 3x cubed for my first term. That's it. Because 1/4 times 3x cubed is 3/4 x cubed. All right, factoring out 1/4 from the second term, I'll end up with 5x squared. See how easy that is? Not bad, right? Factoring out 1/4 from 7/4 x leaves me with 7x. See, you guys are catching on. And now, remember, factoring is division. 1/4 goes into itself how many times? Exactly, once. So you have to put the 1 there, ladies and gentlemen, and that's the result of problem 5A. That's right, coming with that red box. There you go. We gift wrapping answers today. Gift wrapping answers. All right, that was problem 5A, and now I'm on to 5B. In 5B, we have 5/9 x to the 7th power plus 2/9 x to the 5th power minus 4/9 x cubed minus 1/9 x. What do you see in each of these terms? Say it. Say it. Exactly. You see a 9 in each of the denominators, right? So we already know that as a coefficient, 1/9 is what they all have in common. And yes, I don't know why that 9 is bleeding there. So let's finish it up by writing another one. There you go. 1/9. A lot better. See, it has a little cape back there. I don't know what that extra piece is back there, but there you go. It has a thick neck. Okay, we'll just say that. Now, looking at each of your terms here, all right, after we got past the point of 1/9 being the coefficient that they all have in common, look at your variables. Do they all have an x? Yes, they do. So you're going to take the variable with the lowest exponent. So I'm going to be factoring out x to the first power because my lowest exponent here is 1. That's right. You didn't see it, but it's there. It's a 1. Okay? So 1/9 x is what they all have in common. From there, we're going to write down what remains, and that's going to be the following. I'm going to have 5x to the 6th power. Not only am I left with just the numerator there as the coefficient, but since I've taken away 1x here by factoring out that x, I'm left with only 6. So 7 minus 1 left me with x to the 6th power here. Then, factoring out 1/9 x from the second term, I'll have a result that is 2x to the 4th power. So once again, I'm left with the numerator, and I subtract 1 from my exponent because of that x to the 1st power there in my GCF. Then, factoring out 1/9 x from the third term, I'll have negative 4x squared. And then finally, ladies and gentlemen, 1/9 x goes into a negative 1/9 x negative 1 times. Negative 1 times. That's right. Because we had a positive 1/9 x going into a negative 1/9 x. And remember, this is division. So anything goes into itself 1 time, but a positive going into a negative, that'll leave you with a negative every time when you're dividing. You got it. So that means, ladies and gentlemen, that we have an answer here. And it's in a red box now. And there you have it. That was problem number 5. We got one last problem for you, ladies and gentlemen. That's right. Problem number 6. And we have decimals. That is why I saved the best for last. Your decimals. Here we go in part A. I have 1 6/10 n to the 4th power minus 2 4/10 n cubed plus 3 2/10 n squared plus 6 4/10 n. All right, kind of rusty on that last part. Plus 6 4/10 n. All right, that's better, right? So now, ladies and gentlemen, what I notice is that if you look at these numbers blindly, with just ignoring the decimal, all right, you would have 16, 24, 32, and 64, right? Those numbers have all, what do those numbers all have in common? Exactly, they have 8 in common. But because we have the decimal in play, we'll say that they have 8/10 in common, son. All right, so we'll end up with 8/10, and the lowest exponent on your variable n is 1. So my GCF is 8/10 n, just like that. All right, and now I'll be writing down what's left over after I factor out the 8/10 n. Well, 8/10 goes into 1 6/10 twice. And I will have 3 n's left over after taking away that 1 from the 4. 8/10 n going into negative 2 4/10 n cubed. 8 goes into 24 3 times. So this is going to be a negative 3 n squared for the second term. Yeah. Oh, you don't like that n snugged up to that 3 like that? Let's give it a little space. There you go. It'll be negative 3 n squared, just like that. Okay. Then 8/10 goes into 3 2/10. That's going to be 4 times. It'll be 4 times. I'll be left with 1 n left over. Then we'll see how many times 8/10 n will go into 6 4/10 n. Well, 8 goes into 64 8 times, so I'll have plus 8 here. All right, and I won't have any n's because I took the only n I had, right? So that's going to be the result. That's going to be the answer. Just like that. Done and done. Let's put a red box around this. Okay, all right. Okay. Then we have 6b, 6b, ladies and gentlemen. With 6b, we have 2 5/10 x to the 6th power minus 5/10 x to the 4th power plus 5x cubed plus 10x squared. All right, and I don't know what that little dot is, so we're going to get rid of that. It's not supposed to be there. All right, so that being the case, ladies and gentlemen, what we want to do is recognize that it looks like 5/10 will go into each of these terms, as well as x squared. So my GCF is 5/10 x squared, ladies and gentlemen, just like that. All right, let's see what remains when I'm factoring out the GCF of 5/10 x squared. 5/10 will go into 2 5/10 5 times. 5 times. I'll be left with 4 x's after taking away 2 from the 6. 5/10 goes into a negative 5/10 negative 1 time, so I'll just have a negative here. Taking away the 2 x's from the 4 leaves me with x squared. All right. Then I have 5/10 going into 5 10 times, because 10 times 5/10 is 5. So I'll have a positive 10 here. After taking away 2 x's from the 3 that I had, I'll end up with x to the 1st power. From there, I know that 5/10 will go into 10 20 times. That's right. It'll be 20 times. And I won't have any x's left over because I'm taking the only 2 x's that I had from that 10x squared. So, therefore, this is my result, ladies and gentlemen. That's the answer. Red boxing it. Yep. Just like that. Okay. So that concludes this lesson on the greatest common factor, ladies and gentlemen, factoring out the GCF, finding the GCF, factoring it out. And as always, I ask that you please rate, comment, and subscribe, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, and if you're able, please donate, as that helps us bring you more free math videos. Peace.
FACTORING. This includes topics such as GCF, that's the greatest common factor, like Obama. The difference of squares. Quadratic trigonometry. Oh Lord, that's when the pig is sick on all 4 sides. The sum of cubes. That sounds like one of them games they play. Difference of cubes. Oh, that's just ignorant. AC method. Yes, honey, because you got to have your air conditioning in Texas. And factoring by grouping.